Good morning, year 13. How's it going, guys? Great to see you all. It's nice that we've got most people in the room already, which is amazing. We're only missing 4 people. We're missing Ben, Tenzi, Ivan, and Mika. Sounds good. I love it. I always have to play like a second of the sound just to make sure that it's working all right. There's Ivan. Ivan rocking up there, loving it. I'm loving it. There's Tenzi, he's in the house. Love it. Right, Ben and Mika. I think what I'll do is I'm going to start the lesson. I'm going to crack on. It's nice to have the kind of register mostly done within 60 seconds of starting. That's really nice, isn't it? So what I'm going to do is I'm going to mark them as missing for now, and then I will update that later when they arrive, which is the right thing to do, I think. Right. Okay, folks. So today we're going to be continuing with kinetics, and we're focusing today on looking at RDS, the rate determining step. So that's what we're going to be looking at today. So I'll share my screen and we can crack on. Learning objectives were on the YouTube channel, if you did notice that. Okay, let's get rid of this. Whoa. Get rid of my keyboard. And we're in the house. We're good to go. I like it. Right. So this is where we're up to. And that's us. Right. You had no homework over the weekend, which was nice because you guys had already finished Kinetics 2, which is fab. 3 learning objectives today. So number 1, I'm going to be getting you guys to understand what is meant by the rate determining step. We're then going to understand how the rate determining step links to a mechanism. And we'll be looking at this from an organic setting the majority of the time. And then we're going to be able to use the rate equation to predict RDS and a potential mechanism. Okay. So a nice, relatively easy start, really. I'm hoping that we can do this in under the allotted time. That would be nice. Just flipping over my power cable. Okay, so RDS, rate, and you'll notice I should be changing my color. There's Mika. Hi, Mika. I'll add you to the register now. Yeah, it's nice for me to do the kind of colors for all these things since I can. Rate determining step. Cool. I always love using that. RDS. And you will see this kind of short form for rate determining. You'll see this RDS being mentioned quite a lot. Most websites will use just RDS primarily in all of their notes. So it's important that I kind of emphasize that it often gets shortened. Oh, hey, Ben. Good to see you, dude. Thanks for coming. I'll add you to the register. Fab. That's now done. Both Mika and Ben are here. Outstanding. Okay, so let's do some notes. So first of all, we understand that chemical reactions often take place I've said it, so I'll write it, often take place in multiple steps. Now, this is something that at GCSE we really don't talk about. We really try to avoid this at GCSE. We're trying to lay those foundations of understanding of what's happening in a chemical reaction. And what we're really doing is really emphasizing that, you put in reactants, you get out products. Can we balance equations? Can we build formulae? And now at A-level, because we kind of see as read, that you guys are able to build formulae and equations now, that we start adding in this added complexity that some reactions don't take place in a single step. I wonder if someone on the chat, what was the first? There are certain reactions that you guys have been introduced to where you see multiple steps, and they quite often include something in that reaction. I wonder if people could suggest words on the chat. This is me doing two things. It's just me trying to keep you guys awake and thinking, and plus checking that you guys are all still in the room. What kind of reactions have you seen? Oh, Emma is on it. Emma, well done, Ivan. Good job. Can I just say, by the way, that question that I just posed was a terrible question. I did not word that well. And considering both of you have given me that, I love it. Thank you. We picked up at AS. What we went from, we picked up one of the graphs. Yeah, one of the graphs from GCSE, our exoendothermic graphs, looking at things like activation energy. And then all of a sudden, we seem to pick up this additional, and every now and again, we'll see this double hump because a catalyst takes place. And we recognize that this is an intermediate and that this is step 1 in the process, and this is step 2. And we can determine the activation energy when looking at these humps and realizing that this is the highest point, this is the biggest hump. So that actually there is the activation energy, which is smaller than what it would have been without it. So we kind of talked about this. We also see it in organics. Yeah, organic is heavy multiple steps. Yeah, so I'm going to, if I put that, we understand that chemical reactions often take place in multiple steps. This is most common for organic reactions. Can someone give me on the chat, please, an example of an organic reaction that has multiple steps, please? I wonder if that I'm hoping that's going to be a better question. So I've had Ivan and Emma contribute. I wonder if I could have Ria, Nikita, Dana, Dat. Be nice to see you guys throw onto the chat. That'd be excellent. Nuke sub, Kayun, can you be specific? I'm going to be using that today, but can you give me the specific nucleophilic substitution that has the 2 steps? Because one of them does and one of them doesn't. Well done, Dat. That's great. Look at that. All 3 are there. I need somebody to fix Kayun's. Yeah, because Kayun's isn't specific enough. Free radical sub, absolutely multiple steps. Elimination, thank you, Ria. Absolutely multiple steps. That's excellent. Really love those 2. The nuke sub needs cleaning up. There's a detail here. Ria? Okay, like ammonia. Thank you, Kayan. Ria, you've just gone completely mad. And that's a bit worrying because you're not understanding what the mechanism's name is doing. You can't have electrophilic nucleophilic substitution. That's not a thing. The electrophilic or nucleophilic are either one or the other. It's the attacking species. Yeah, so you can't put those 2 together. Yeah, they're independent of each other. Okay, so I'm actually going to be using Kayun's today. So if we look at nucleophilic substitution, let's do, and I'm going to do it properly like I'm in an exam. I know I write nuke sub a lot of the time. You're not allowed to write, of course. Sorry, I forgot. Oh, no, Ria, no sorry needed. Nuke sub, nucleophilic substitution. Nucleophilic substitution. So we picked up nuke sub. I'm going to star it. Yeah, we picked up nucleophilic substitution. And we picked up 2. Yeah, we saw 2 different versions of this depending on our nucleophile. Now, this is going to be further expanded over the next few lessons. Yep, so we have got, let's do nuke sub number 1. Let's do nuke sub with ammonia. Yeah, let's do it with ammonia. Actually, no, we shouldn't do that first because that's the more complicated of the ones. Let's go cyanide. Yeah, now I'm really emphasizing this, folks. Look how I have drawn the cyanide ion. Yeah, I have not put the charge on the end. Ugh, no, do not do that. I am not, the lone pair is specifically on the C. Please, 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 you've got to know that. It is important. That charge in the wrong, could we do it with OH minus instead? Yes, can. Would you prefer that one, Nikita? Do you feel more comfortable with that? I can do it with either. It actually makes no difference in this particular setting. So we learn that if we do, let's pick up a haloalkane. Yeah, on the chat, please. On the chat, can everyone please, number one, no, it's okay. Okay, Electrophilic Addition, EA Sports, it's in the game. Yeah, Electrophilic Addition is not, it is two-step, you're absolutely right. Yeah, it can. I'm just thinking in terms of Rhea's elimination. Elimination's not usually two steps, it's usually a one step. I was actually looking for EA Sports Electrophilic Addition. On the chat, guys, number one, can you name it? Name. And number two, can you classify? Classify. Yeah, can you classify my halo, please? Just name and class. Okay, so let's do this for cyanide. So number one, we have the reagent. I'm just doing a little bit of AS revision. Yeah, the reagent is the name of the substance added in the reaction, the full name. In this case, I'm going to use sodium cyanide. I could have used potassium. I actually prefer KCN than NaCN. Not that it makes any difference. It's just KCN's more common. But this is the reagent. And the reactive species, yeah, noting there is a difference. The reactive species, which is what is shown in the mechanism, yeah, is CN minus. Notice I'm circling my charge. Emma, 1-chloroethane. Well done, Emma. And Nikita smashes it with a primary halo. Well done. That was a superb tag team, that was. 1-chloroethane is correct. It's nice. I hope you realize it was actually a trap. I wrote it to see if people would call it methyl. 1-methyl chloromethane. Yeah, but yeah, well done, Emma, for seeing through it. It's great. So this is 1-chloroethane. Yeah. This bit here is not a branch. It's just part of the long chain. I've just written it like that to try and throw people off the way that they do. And this is a primary haloalkane. Can I say well done to Nikita for remembering the haloalkane? Lots of students, most common mistake is they will simply just write down primary and they'll lose it. Okay, so we've got our primary haloalkane. We're going to add on our reactive species for the mechanism. I'm actually going to make my pen a bit thinner here. Here's my cyanide ion, circled charge. Yeah, put it nearby from the middle to this. Oh, I've forgotten step one. Step one, find my deltas. Without my delta, there's no attack. Cyanide goes in, and that now breaks off. Now, we taught this to you as a single-step process. And in reality, it kind of is. You write this as a single step. Ooh, I'll explain why. So, by the way, that is what I'd like to think that you guys have built before I even finished my notes. Yeah. So we'd see this as a single step process. However, and this is where I need to kind of deviate a little bit. I don't especially want to actually. This is just going to be a bit of a heads up for the next lesson, folks. Yeah, I'm going to incorporate this, I think, into the next lesson. So just to let you know that there's a bit of an awkward thing with this. This process, this reaction, this one step is called an S. Do I want to do this? Yeah, I'll teach you this next lesson. This here is called an SN. Oh, that was weird. Laptop hiccuped. It's not going to do this. I don't know why you guys seem to always hit me with this faulty pen malarkey. I don't know why it happens with you guys, but it does seem to be a bit of a habit. I don't know why either. It's a bit frustrating. Let's see if it works now. SN. Oh, are you messing? I don't know whether or not it's the... What a nightmare. It's gone and done it again. And I don't know why either. Is it my pen? I really wish I knew. What I'm going to quickly do is quickly change the battery on my pen, folks. I think that's a wise decision. If I can find my spare battery, that is. Oh no. Spare battery, spare battery. Where's my spare battery? What a nightmare. Hang on, folks. Nearly there. Nearly there. Let's try that. Let's give that a go. Don't know if it's going to work. This will tell me whether or not it's the pen, it's the tablet. Oh. What a nightmare. I honestly don't know what's causing it either, and you guys seem to get this every time. Close that again. I'm going to close down all of these things. Let's get rid of all of this stuff. All of this stuff. Don't think it's going to make any difference. Right, let's see what that does. Is it going to make any difference at all? I feel like maybe it's a setting. No, look at that. Still doing it. Oh dear. Oh dear. This becomes problematic when it does this. No idea how to fix this. I've had issues with this. Maybe you dropped it too much. I honestly don't know why it does this sometimes. It seems to be getting more common. Device. Don't know. Bluetooth on. Paired pen. See, the pen's even at. It's even at 61%. It's not like it's actually. I don't know why. Maybe I should turn it off. Oh. Draw a shape to create a screen snap. That's not what I want. Improve recognition. I'd love to know whether or not it's the software. Look, it's still doing it. I don't know why either. Maybe I dropped it too much. It's not going to make any difference either. I've got a feeling that I'm not going to be able to get away with this now. I don't know why it does this, folks. I might switch to my other. I might have to. I don't know what's going on. It's hiccuping, and I don't know why. It shouldn't do this. Should not do this. I don't really want to end there. I don't really care if you guys are hanging around. It should not be doing this, and I don't know why. Let's turn the pen off. I don't know why it would make any difference, and it's not going to do anything, is it? It's not going to make any difference. No, it's proper hiccuping. So strange. Ah! I feel like the pen is the problem, but I'm thinking maybe it's not. I think I'm going to have to... Yeah, the pen is really just not functioning at all now. Guys, I'm just going... What I'm going to do is stay here. I'm going to restart the laptop, and then I can hopefully rejoin this. I don't know whether I'll be able to. Let's see. It just needs restarting. I'm not even going to end the broadcast. I'm just going to... Can I pause a broadcast? Leave studio. I don't really know what that means. I'm going to restart. Stay where you are. It shouldn't be more than a couple of minutes. Restart. That's very irritating. Add to stream. Ah, I'm back. Can you guys see me okay? Going to share my screen again, see if I can get this back. So that's interesting. If I don't end the broadcast, it does suggest that I can do that. Hide that one. That one. That's what this was. Can you guys still there? Let me know, please. This will work now, annoyingly. Yeah, okay. So, are you guys still there? See, look, it's fine now. Stupid thing. Yeah, okay, fab. Okay, so we would look at, yes, fab. Thanks, guys, for sticking with me. I'm sorry that it's being a pain. Okay, so this is called, and do you know what? I'm going to bail on this bit, guys. There's no point. I'm going to do SN1 and SN2 on a separate lesson. I'll do this next time. Okay, so we realize that this reaction is deemed a single step. Yeah. What that means is if it was a single step, then we would recognize that we need in this reaction, we could write an equation, which would be sodium cyanide, the full equation, the overall equation would be this, CH2, no, CH3, CH2, Cl, there we go. Yeah, and what I'm going to get is I'm going to form sodium chloride, and I'm going to form a longer carbon chain. We know, a nota bene, we know the reason why we use toxic cyanide is because we extend the carbon chain. It's a lovely nota bene to make that. That's why we do it. It's the only reason. Okay, so we could then turn that into an ionic equation, recognizing that the sodium chloride and the sodium and the chloride ion are doing anything. So we could turn that into an ionic. Cn minus plus CH3, CH2, Cl, and we're going to form CH3, CH2. Sorry if you don't like the fact that I swapped over the two people. There's the ionic equation. Yeah, the Cl can't be discounted, can't be not included in the equation because it's part of the organic at the beginning. Yeah, it went from being a liquid to aqueous. So anyway, so we can look at that and say, if this here is a single step, well, I think everyone here would agree that I have got one. This is where changing my pen sizes. I have one. Probably better to go a bit thicker than that. I have one of these and one of these. Yeah, well, if that is if that mechanism is absolutely true, yeah, and there is nothing else involved here, then we can predict a rate equation. The rate equation would be K cyanide to the power of 1 and CH3 to the power CH3, CH2, Cl to the power 1. This is what would be called a predicted rate equation. Now, Kayun is going to go, hang on a second, Mr. Duncan. You told me that the rate equation has nothing to do with the stoichiometric ratio in the balanced equation. You asked me that, Kayun, a long time ago, a couple of lessons back. Well, this is predicted. What that means is it is not guaranteed. We would have to do the experiments of changing these concentrations. Yeah, change this and change this. Yeah, while keeping others the same, you know, the game of this. Yeah, we're going to change these in order to be able to find out if this is true. Now, it would be classed as a predicted. Now, what we now need to realize is, well, hang on a sec. Well, how does the rate equation actually link directly to a mechanism? Well, what I'm going to do is I'm going to make a simpler version of this. Yeah, I'm just going to make it really, really simple to be able to show you how this works. So, and we've got to look at ones that are multiple steps. So we're going to look at RDS. So first of all, we need to define what RDS is. RDS, the slowest, underline it in a different color, the slowest step in a reaction. The slowest step in a reaction. And it is said to be rate determining. The reason being, if I have A plus, let's go for an EG, A plus B goes to C. C plus D goes to E, and E plus F goes to G. And what we're trying to do is, we can create from these, we know already from AS chemistry, number one, this is a 3-step process, and we could combine them. Yeah, we could combine these. Yeah, 3 steps, we can combine equations, yeah, to create an overall equation. On the chat, please, can you please give me the overall equation for those 3, please? Please give me the overall. Whilst you guys do that, what I'm now going to just mention to you is that one of these will be fast and slow. Now, there's no hint in this particular question as to which one's which. We'll see that later. Let's say, while you guys are writing onto that one, I can just give you some details. This one is fast. Step A is fast. Step B is slow. And step 3 is very fast. Okay, so what that means is, if the second step, this step here, will now be classed as RDS. It is rate determining. Now, the reason why it's rate determining is because the step 1 is going to produce C very quickly. C is going to build up. And then C's got to get and then be used in step 2, which is slow. And we can't do the last step until E has been made. And as soon as E is made, it's going to be destroyed in step 3. Now, the analogy for this is often described in a journey. Yeah, it's often described this is an analogy. I'm wondering whether or not you guys, I still haven't had anyone post the overall equation. Nobody. Let's have a look at the overall equation. Yeah, so the overall equation, C got made and then destroyed in step 2. Yeah, D produced E. E was then destroyed in the next step. So the overall equation for this reaction is A plus B plus D plus F. Uh-oh, I feel like something's happened. It's just giving me this screen. Oh, has something happened? Uh-oh. Has something happened, folks? Have I lost you guys? Oh, no. Can you guys see me? Have I lost you? I feel like I've lost you guys. I did put it in the chat. Oh no. I haven't received anything. Uh-oh, something's going on. Amazing. We can see We're only missing 4 people. Put it on the chat. I'm so confused as to what's going on. Because my YouTube says it's still functioning. I don't know what's going on here, guys. I've got people messaging me and it not even coming through on my laptop. I don't know. You said you put something on the chat. It's gone. Oh, has the chat been stopped? Oh, it's possible. Right. This is a nightmare. It's just giving me this screen. I don't know what Nikita is sending me. Oh dear. Okay, so that's all you're getting, right? Eek. That's weird. Nikita, is that just you or is it everyone else? Oh, this is not a good lesson. I'm going to delete this from YouTube after this. Can you guys see me? I'm going to say that you can't. I've lost everybody on the chat. Everything seems to have gone quiet. Yes. So you can see me okay? Okay. Right. So if I share my screen, we can. Okay. I think the chat paused for a bit. Yeah, I think so too. What a nightmare. Okay, let's go back to this. You put it on the chat. That's fair enough. I think the chat got busted. No problem. Okay, so I'm going to give up on the chat, I think, today. I think the chat paused for a bit. Yeah. Okay, and that's going to produce G. So there's the overall equation. I think everyone's now okay with this. Can everyone now see my board? What a mess this has been. Oh. Can everyone see my board? I hope so. Right. Let's just continue, and then I might do it again if it needs to be. Okay, so what we realize is right, yeah, brilliant. So the overall equation simply tells us what needs to go in to produce G. Yeah, that's all it tells us. Yeah, what goes in, what is needed to make G. What it doesn't do to make G, what it doesn't do is tell us how the mechanism proceeds. Agreed? Now here's the clever bit. Because we've got a slow step, what we realize is in the rate equation, rate equals K, there are only going to be 2 people in it. Well, that's not entirely correct. It doesn't have to be, but I'll show you in a second. So they are going to be c to the power, okay, there's actually 2 alternative rate equations here, which is frustrating. I'm not done very well here. C to the power 1 and d to the power 1. Those are the only people that are going to be in the rate equation. The reason being is it will not matter. It will not matter about the concentrations of A and B because it was fast. And therefore, what A and B's concentrations, as you put in, it's going to create, say, this is a nightmare with this, which is there is a second rate equation. It could actually be this. That is actually exactly the same thing as the top one. Oh, God, what a nightmare. Those 2 equations, those 2 equations are the same. Because A and B make C, yeah, but D is needed, so those 2 rate equations are actually the same thing, which is a nightmare. I shouldn't have I've given you a bad example. This is not going well. Oh, let's start again. Let's start again, folks. Let's make this, I'm just going to go simpler. Yeah, so okay. I think the best way of doing this, folks, is I'm just going to teach you this in terms of questions-wise. Yeah, and then it'll make sense. Okay, so we know what RDS is. It's the slowest step. You need that one. Tick that off. You know it's the slowest step in a reaction. We know this. Next question. Let's do this via questions. Question 1. Question 1. Let's go for A plus B plus goes to C plus. C plus D minus goes to E. And E plus F goes to G. So what they're going to do is that in these questions, there are different types. And this is the first one. So it gives you a reaction. The question could be A, give the overall equation. Yeah, everyone's okay with this. B, which step is fastest? Now, that's an interesting question because it's the opposite of RDS. Agreed? Yeah, they would then say, which steps, in this case, multiple, could be RDS. Now, that question is a big hint. Yeah, it's a big hint because it's telling you that there is no one correct answer for this one on RDS. They're saying there's one correct for the fast. Yeah, I'm going to call these step 1, S1, S2, and S3. So I'm not going to bother to ask you guys for the overall. I think you guys are good at this. Can somebody on the chat please tell me which one they think is going to be the fast step? Just making it a bit clearer. Yeah, which one's going to be the fastest? Which one's going to be way fast? Tray fast. Yeah. The second, thanks, Dat, spot on. The second step is going to be very, very fast. Very fast. That's B. Yeah, this one's going to be the answer. The answer over here is going to be S2. Yeah, this one's going to be very quick. Now, the reason why Dat knows that is because opposite charges attract. We know this. Oh, just going to shrink my pen. Yeah, opposites attract. Yeah, so that's going to be a really, really fast step. Yeah, now the other two are interesting. The other two, so the answer to C is step 1 or 3. Yeah, S1 or S3. We won't know. The reason being is there's no reason as to being, I know that this one has a positive charge, but because A is neutral, it makes no difference that B is. These two here could be both RDS. There is no reasoning. We'd have to do the experiments to be able to find that out. Let's now look at question number 2, Q2. Okay, and you'll realize I'm just giving you different kind of ideas. I'm trying to get this concept of ideas through about what could be an RDS. Let's go for, I'll use different letters to make it clear. X plus Y plus goes to Z plus. Z plus plus Q plus goes to W2 plus. W2 plus plus P2 minus will go to M. Yeah, okay. So this question's very different because what they're going to do is the questions change. A would be continuing to say overall. Yeah, so this is just a combining. I'm actually going to give you the answers to this above in a set to the other previous one. Oh dear, got more people messaging. I'm wondering if there's problems. B would be which step is RDS. Now, notice the change, the subtlety in the change. This is now not giving you, this is not saying that that which one could be. It's saying which one is. So that means there's only one answer to this now. Yeah? And then they could also say which step is fast. Which step is quick. Yeah, I'll put fastest. So one's asking for the slowest, one's asking for the fastest. Now, just going to give you the overall for those people who are doing this on the lesson. Yeah, and they want their answers, of course. Recognizing to combine this one, C is going to cancel. E is going to cancel. My overall would be A, which is neutral, plus B plus and D minus plus F goes to G. There's my overall for that. It's nice just to give the answers for those. Yeah. Okay, overall equation for this one. Overall equation for this, the Z plus cancels. Yeah, the W cancels. Similar kind of thing. Yeah, X plus Y plus Q plus P2 minus. Notice the conservation of charge still works. It's amazing the way you see that. I love conservation of electric charge. It's one of the most useful things I picked up. Okay, which one's RDS? On the chat, please. Which one is RDS, please? And this is very obvious. Which one's going to be the slowest? So if Dat spotted the fastest, yeah, I think everyone here will be able to say, well done, Ivan, well done, Dana, great job. Dat's on it too. Yeah, I think everyone's got this. Yeah, RDS is step 2. And of course, I think everyone can see it. Yeah, if opposites attract, step 2, due to like charges, yeah, like charges repel. The activation energy, therefore, will be extremely high. They're not that the chances of them going to EA is très high, very high. Yeah, because in reality, we realize particles need to collide. Just to quickly draw that as an image, particles need to collide. Who did I actually have on this? I had Z plus and Q plus. So if we've got Q plus and Z plus, and these guys need to collide, the problem is they're going to repel each other, which means when they get close, they're going to be literally pushed apart from each other. So in order to get these things to collide, we're going to have to crank up the temp, yet to extreme amounts to get these guys to collide. So the activation is high, therefore the reaction's therefore going to be very slow. And the fastest, of course, is going to be step 3 because like charges attract. It reduces the activation energy. I think this kind of makes sense so far. everyone's kind of going, okay, I'm with you now. I'm understanding why that one would be slow. Okay, next. Now that we can identify RDS, we now have to go to a slightly more complicated one. We now can recognize, so I'm tempted to add this to my learning objectives. Yeah, link to mechanisms, understand rate determining step. We know what it is. We know it's the slowest step in any reaction, and we can spot it using charges. We can recognize it. So I'm going to add that in here, not just an understand, but I'm just going to add recognize simple RDS steps using charges. Yeah, I'll put brackets charges. Very common at A level. Yeah, okay. So now we need to do a slightly more complicated one. Yeah, we now need to go back to one that charges don't apply to. So if I now have, I don't know, F plus G goes to H, H plus I goes to J, J plus K goes to L. Right, what they're now going to do is they're going to give you these steps, S1, S2, S3, and they're going to then tell you what the rate equation is. Rate equals K, F to the power of 1, and G to the power of 1. So, as a result of that, you can now say, question, RDS, question mark. Can everyone now tell me what they think RDS is going to be? It says not complicated. And that is the only thing, no, they can do an explain. Yeah, explain, which is the one that everyone will struggle with, so I have to give an example. Yeah, everyone here can now give me the step for RDS. Thank you, Dat. Yeah, the answer is 1. So first step is RDS. Thank you. And the explanation, thank you, Dat, thank you, Donna, thank you, Nikita. And the explanation is the reactants are in the same ratio as found in the rate equation. The rate equation. Okay. Now, this will become clearer the more you do these and the more you see them. In reality, these are just kind of tricks and games in reality. Yeah, the mathematics behind all of this stuff is pretty epic, and you don't need it. Yeah. So let's go to the next one. Question number 4. I don't like the fact that I made my pen bigger. Don't like it. Let's make it go back to normal. Cute 4. Okay, let's go to this one. Let's go x, 2x plus y goes to z. Z plus w, try that again. Z plus w goes to q, and then q plus p goes to n. I don't know, I'm just messing around, just giving you letters, doesn't matter. Right, and they're going to give you the rate equation of this one. Rate equals k, x to the power of 2, x to the power of 2, y to the power of 1, and w to the power of 1. Right, there you go. So, A, which one is RDS? And B, I would say explain again, but I don't think, it would always be explain. And you say the same thing. The reactants are in the same ratio as found in the rate equation. I'm not going to bother with that. I'm going to ask you for the overall order. Let's do that. Overall, it's just nice for me to bring back all of these questions. You realize everything comes back. Step 2, thank you, Donna. Thank you, Dat. You guys are on this. So the reason why, why? The reason why is because we realize that Z could actually be replaced because we realize that Z is made from 2 X's and a Y. It is overall order 4th. Well done. Good job. Yeah, 4th order overall. But this one is now RDS. Yeah, RDS is step 2. because Z could be just simply replaced with 2x and a y, because we realized that the first step made it that way. Yeah. So this isn't a particularly complicated issue. I want to show you how you can actually predict mechanisms. This is where I make them. By the way, the next bit is a bit messy, to be fair, because trying to make up these things like this is a bit tricky when you get to making up mechanisms. But I probably can do one. Let's do Q5. Q5. So, oh, actually, do you know what? I'm just going to do one more of these. I'm going to do one more of them. Yeah, one more. Let's do L plus M goes to P and Q, and then P and P and O goes to M. Let's just do that. Yeah, we could do P plus Q. Okay. So what I'm trying to show you here, guys, is I've got two reaction mechanisms, two pathways. Yeah. And the first thing to point out is that if we look at the overall equation for these two, they should be the same. Let's see if they are. Yeah, P is going to cancel. Yeah, M's going to cancel. Oh, no! M cancelled. Can't do. Oh, actually, that's entertaining. Sure, we can go for that. Done. All right, I've done it now. The overall equation, that will cancel with that. M was a catalyst. L plus O goes to Q. There's the overall. Let's do the next one. It's my boss. Always love it. L plus O gives me Q. Perfect. They give me the same overall equation. Yeah, we realize that just from our process of being able to combine equations. Well, if we now look at the rate equation, the rate equation is this. K, this is where I make a mess. Yeah. M. Got to be really careful here when I'm choosing this one. Got to be really careful. Darn it. Not doing a very good job today. Oh, okay. Let's just do that. Let's just do that. We'll keep it simple. Okay. So if I gave you that now, out of these mechanisms, let's call this mech 1. Mech 1 and mech 2. Which mechanism now fits my rate equation? And of course, this is a very, very easy example. Just trying to make these in my head. Even I struggle with them because I've got to kind of see it all through and I can't get that far. It's my dyslexia holding me back. I've got to let you guys go now. Guys, I'm going to leave you be. The answer was mech 2 because X only appears in mechanism 2. Yeah, thanks, Dana. Right. I'm going to end the lesson here, folks. It's not as complicated as this. Is much more about having a look at how the questions are going to come at you. I will post on the Classroom your homework for today's lesson. When do I have you guys again next? Mechanism 2. Thank you, Ben. Thank you, Ivan. Good job. Yeah, when do I have you guys again next? I have you guys tomorrow. Homework is for tomorrow. There's only a few questions. It won't take you very long. It's dead easy. Just to let you know, by the way, that it is possible for you to have a rate equation that doesn't have all the intermediates in it. I'll explain that to you next lesson. It'll make sense when you see the questions. I'll post that. I'm sorry that the lesson has been such a mess. That really has been a bit of a disaster. But guys, I hope you have a nice rest of your day, and it's nice to see you all as normal. And I'll see you all tomorrow for hopefully slightly better lesson. See you later, guys.